Okay, let's start with the main topic for tonight, which is simultaneous equations. And this is what you do to solve a simultaneous equation. You need to find pairs of x, so x equals something, and y equals something, such that those x and y will satisfy both of these equations at the same time. So that's what it means to solve simultaneously. However, if you solve these two equations simultaneously, they also represent the graphs of that equation represents a graph. So I'll call it the yellow graph. And this equation over here also represents a graph. And just because I know functions pretty well, if you wanted to visualize what the simultaneous solutions would be, this is a parabola. So that graph would look something like that. It's like a happy face graph. And this would be a straight line graph, and it would look like something like that. And so when we are solving simultaneously, we're actually solving for the place where the two graphs meet each other. Now, we don't know what the answer is, but we do know that, we know roughly what neighborhood they're in. And so what we do, the easiest method, if given a choice, is a method called substitution. And what we do for substitution is we choose the easier of the two equations. Which one do you think is easier, the yellow or the green? Which one do you think is easier, the yellow or the green? The yellow. Well, the yellow is easier in some ways, but remember that this is a straight line graph, that's a parabola. And so what I was thinking is that the green was easier if I wanted to sub the green one into the yellow one. I would work first with the green one, and I'd make y the subject of the formula, and I'd go 1 plus 2x. And then I would take that, and I would sub that one into the yellow one. And the reason I do it is that if I do that, so 1 plus 2x is y, I can then have that equation, which only has one variable. So what I say is you go from the easy looking one and you sub it into the harder looking one. And also when you're given a choice between the two variables, the 2x looks harder because it's got a 2 in front, where the y looks all easy and by itself with a 1. So step one is to substitute from one equation into the other. The next step is to then solve that equation. And that reminds us of the last lesson where it was a simultaneous equation. So what we do is we then move everything to one side. So I'm going to move, the minus 2 is already there. I'm going to bring the 2x across. I get minus 2x, and then I've got minus 1. And so then my standard form for this quadratic equation is 0 equals x squared minus 2x minus 3. Give me a thumbs up if you followed what I've done so far. Give me a thumbs down if you haven't followed what I've done so far. Okay. So now we have to solve this quadratic equation. Now you can use a formula if you like the formula, or you can factorize it. I'm going to factorize it because it's not too difficult a thing. So x minus 3 and x plus 1, in which case 0 equals x minus 3, or 0 equals x plus 1. And so then x is going to be equal to 3, or x is going to be equal to, oh, sorry, that was a bit much. X, oh goodness. X is equal to minus 1. Am I done? No, because it said find me what x is. So we found the x's, but we still have to find the y's. And the way we find the y is we go back to this original equation that we isolated y with. We take this one over here. I think it deserves its own color. So y equals 1 plus 2x. And we're going to use that to help us. And we're going to say y equals 1 plus 2 times something, or y equals 1 plus 2 times something. But the something is not a mystery. The something is going to be 3 in this case, and the something is minus 1 here. So what are the y values that are answers to the simultaneous equation going to be? What are the y values that are the answer to the simultaneous equation going to be? And you can pop your answers in the chat. Pop it in the chat. So 2 times 3 plus 1 is 7. 2 times minus 1 is minus 2. Minus 2 plus 1 is minus 1. So my final answers would be x is 3 and y is 7, or x is minus 1, y is minus 1. And if instead of writing it separately like this, we wrote them as coordinates, the intersection point of those two functions would be 3, 7, or it would be minus 1, minus 1. And I'll just show you this is true. Now, this was an approximate graph, but you can see that that point over there would be the point 3. And I know it's not perfect. That would be the 7. So that's the point 37. And then the one over here would be the minus 1, minus 1 point. And so those are the two simultaneous solutions, but also the intersection points. Give me a thumbs up if you followed that example. I'm going to let you fly solo now, but I just want to check that you're ready to fly. Okay. Well, then, my students, it is time to fly. So you need to solve for me simultaneously these two. So I want to find the one way of saying is, can you find the intersection point of these two functions, or can you solve for x and y simultaneously for this pair of equations over here? So we have a yellow one and we have a green one. And I want you to find me the value of x and y that satisfy both of these at the same time. Over to you. If there's a question, I will watch the chat. Or I'd love to hear an audio question if someone feels like they want to ask that. It can be quicker than typing. You know, everybody likes to do a voice note nowadays. To maybe audio things are even easier. So step one is actually replace the y here with the y on this side. So you have to go from there. Visually, what this would look like would be the green graph would look something like that. And then the yellow graph probably look, it's hard to know exactly where it would go, but the yellow graph would look something. You don't have to draw the graph now. We're just doing algebra, but I'm just adding it so that when we get to functions later on, you have some idea about what's going on. So I want to see those x values, or I want you to say done in the chat when you are done, so I know you've solved it. Either say done or put the X values in the chat when you've solved it. Okay. What we do for this one? Three should not go there. So that should be 1 and 1. So what are you getting for your X values? Are you getting the same as me? I seem to be getting X is a half or X is 1. So watch out here. You've got 2x minus 1. The 2x minus 1 thing, when you bring the 1 across. Okay, cool. Perfect. Okay, let's get our y values. So to get the y values, let's do this. All we do is we take the easy y formula above. So we go y equals 3 times something plus 7, or y equals 3 times something plus 7. And then we put whatever we got for x in there. So what are my y values that are going to go with that? So Sange, I agree. This is clearly 10, and this is clearly 8.5. So my final answers would be, the simultaneous solution would be x is a half and y is 8.5. Or we could say that x is what? Is that right? X is a half, yes, and then x is 1, and y is 10. Let's just check that we haven't made any silly mistakes here. 2x squared minus x minus 2x minus x, 3x plus 1 is fine. A half and 1. Yes, that's correct. So my drawing is just not very good to scale. But we should get a half, 8.5, and 1, 10. 3x plus 7. Yeah, perfectly happy there. Okay, give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. I think we're ready to move on to a different one. Just give me a quick indication about how you're feeling, so I know if I should do another one like this, or I can change to a different type of simultaneous. Okay. So what we are going to do now is we are going to solve this simultaneous equation. And the way it's worded is it says, find the coordinates. Okay, it says find the coordinates of the point of intersection, so where they meet, of the two graphs graphically. Now, we're not actually going to use graphical methods. We're going to use algebra. So just to draw your attention, the two things that we are focusing on is that and that. So I'm going to rewrite them. This is what we call a hyperbola, and this is what we call a straight line. I'm going to call this the blue one, and I'm going to call this the red one. And I want to know or I want to start. What is my first step? What do I need to do to solve for the points where these two meet, or solve for x and y simultaneously? Who knows where I'll start? To give you a feel for what the two graphs look like, the blue one would look something like that, and the red one, x minus 1, it will look something like that. And so we're sort of looking for what these two green points are. Yeah, so we just have to sub. Exactly. So we could say x minus 1 from the red one is equal to 6 over x. And so we've got rid of the y. What would be my next step after that? Because now I have to solve the black block. Solve for x. Yep, Amy. Now, the thing that is causing me a bit of stress is this x at the bottom. And so we have to multiply both sides by x, or another way of saying it is just divide by x on this side, it's times on that side. If we multiply both sides by x, essentially, now I must be careful, this thing must be in a bracket, but I multiply this side by x, and if I multiply this side by x, this cancels, and I'm left with x times x minus 1 is 6. I want you guys to solve this simultaneous equation for me and get me values of x that solve this. And then I want you to put the answers in the chat. Yep, so that's a good first step. You multiply out and you move the 6 across, and then it's in standard form. And now you have a choice between factorizing or using the formula. So what do we have? I think we have that. In which case, and I'm going to start skipping, instead of going x minus 3 is 0, I'm just going to go straight to the answer. X is 3 and x is minus 2. But now I want to know what my y values that go with that should be. So I look back, which one looks simpler? I think the red one looks simpler here. So I'm going to use the red relationship to y and say something minus 1, or y is equal to something minus 1. But that something is 3 in this case, and it is minus 2 in this case. So what's my final answer going to be? Y is going to be 2, and y is going to be minus 3. So the intersection points will be 3, 2, or they would be, put that down, or they would be minus 2, minus 3. And if you look at the points, the point 3, 2 is going to be this intersection point up here. And the point minus 2, minus 3 would be where the graphs cut over there. All right. So I'm throwing in a bit of functions to show you that when you solve two equations simultaneously, they're also the intersection points. Give me a score out of 10 about how you're feeling about simultaneous equations so far. So 0 out of 10 if you feel like there's no hope. 10 out of 10 if you're like, I'm the ninja of the neighborhood in this, out of 10. Okay. So I think before we go and have a break, before I think we need to really tackle the hardest one I can come up with. So I know there's 4, yeah, we can do it. Okay, let's do it as a team. I want you to solve this one simultaneously. Now, what makes this more difficult? Who would like to say what makes this solving this more difficult? I think it looks more difficult because they both look very detailed. But given a choice between the two, I think this one looks like the easier one, and this one looks like the harder one. Now I have to choose something to sub into. I need to sub the green one into the blue one. But I also need to choose a variable. Should I choose the x to make the subject of the formula, or should I choose to make the y the subject of the formula in the green equation? Are you pink or are you blue in terms of the variable you want to choose? I think it's the y as well, because it just feels like the y, because it's got no number in front. So I'm going to say this is minus 2x plus 2, and at least I now have one equation. Now I need to sub this into this one. I want you to go ahead and write in what you would do if you were subbing it in, and when you're done, I want you to say done. And I want to see if your answer is the same as mine. I don't want you to go and complete it, because if you finish it now, you might make a silly mistake. But I do want you to sub the green into the blue and tell me done when you've done your sub. And then I will give you some feedback. Okay, so what I always do is I leave a space for the thing I'm subbing in, and then I go and sub my thing in. But I've made a mistake already. Can you see my mistake? I suddenly left out the squaring part. So that's kind of a big deal. But luckily I spotted it. And then we have minus 2x plus 2. And then that has to be multiplied by that. So if you sub in correctly, you'll notice there are no more y's around. In fact, let's use a different color. What color should I use? Blue? Let's use red. So I now have this, but I have to simplify it. So I think the most difficult things to simplify are over here and then also over here. If I can get these bits right, I'll be okay. So what I'm going to say is the following. The key idea here is to realize that squared actually just means that. When you square something, it just means repeatedly multiply those two things. And then the other tip I'm going to give you is I'm going to say, leave the 3 in front and then just multiply the x by the minus 2x plus 2. Or another way of saying it, you know what it is? The best thing you can do is move the x to the front, and you have 3x, and then you have minus 2x plus 2. If you write it out like that, it's unlikely you'll make a silly mistake. But the really important thing is to notice the bit in yellow and to also notice the bit in green where you move the x to the front and you do it like that. I want you to try and multiply it out and then get it into what we call standard form. So once you've moved everything to one side, you're going to get naught equals something. And then I want you to tell me what you end up with. Or tell me done when you've got this into standard form. So tell me done when you are. Okay, you guys are Speedy Gonzalez today. I need to make sure I do this properly and no silly mistakes. Plus 4. So that's the one side. And then on this side, it's minus 6x squared. There is 6x squared, 2x squared plus 4x squared. But then what about this poor minus 6x squared? That should be 12x squared. And let me just double check. Then I've got minus 4x, which is minus 8x. Then minus 6x. So that is good. So this is fine, this is fine, this is fine. If I want to reduce that, I'm going to get 6x squared. So divide that by 2, divide that by 2, divide that by 2. Rulani, you are perfectly correct. You guys are on fire. Well done. Now, let's see if we can get our answers for this, or if I'm going to need to use the formula. I don't think I can get there without using the formula. So I think this one, I have to use the formula. I don't see an easy factorization. And so if I'm going to use the formula, I'm going to go A is 6, B is minus 7, C is 2, and the formula looks like this. And I have to plug my values in to solve this. So minus 7 plus minus, then b squared minus 4 times something. The b is minus 7. The a is 6. The c is 2. And on the bottom, we are going to have 2 times a, or 2 times 12. So we get 7 plus minus. Now, that's 48. That's 49. So delta is 1. And this will be 24. And so what is x going to be? It's going to be 8 over 24, or 1 over 3, or 7 minus 1 is 6. 6 over 24 is a quarter. So I get x is a third, or x is a quarter. Did anybody get that as well? Give me a thumbs up if you get x is a third and x is a quarter. That's why I couldn't get it. I seem to struggle to get it with my normal factorizing. Okay, fantastic. Now get me my y values, and then it's time for a break. I'm pushing you guys deep into overtime here. So you know what your x values are. What are the y values that go together with that? I'll even put it on the screen, hopefully. Or actually, I'll write it down. It's y equals, what is it? What's this thing at the top here? Minus 2x plus 2. So y equals minus 2x plus 2. So that is what I have to use to help me get what? So I put a third there, and I put a quarter there. Help me out with your calculators, ladies and gentlemen. What do you get for your y values? So Sange gets 4 over 3, or 3 over 2. I agree with you. So this is 4 over 3, or that is minus 2 of what's minus a half plus 2, so that gives you 3 over 2. Yep, I agree. So the two answers, the simultaneous answers are x is a third and y is 4 over 3, or x is a quarter and y is 3 over 2. Wait, let's make sure I made that correct. Yeah, that's correct. That was a toughie. So, but it was doable, I think. So give me a happy face or a thumbs up if you followed most of that. Remember, you can re-watch the recording on this if you need to. It's not, you don't expect it to get it perfectly, but just give me a feel for how, if you followed the logic on that one. That was a real toughie. We're doing it all the way from up here, where we did some work, and then we had to use the quadratic formula because the things were fractions. All right, everyone, we've gone way past our break time, so it's time to turn on your cameras. It's time to join me in a bit of an unwinding session so that we can, Rulani, I'll come to you right now. I see your hands up. We're just going to do a little exercise session so we can make the most use of the last part of the lesson. Okay, so what I want you to do, I want you to turn on your cameras, stand up nice and tall, and I want you to breathe in, hold, breathe out, and breathe in, breathe out, breathe in, oh, that felt so good. Okay, we want to loosen up. We've been sitting for 40 minutes. We've been tense. We want to just loosen up the arms. So just flap those arms around, nice and loosey-goosey. Flap this arm around. Flap both arms around like one of those wavy men in the wind. You know, those plastic blow things, you know, when their arms go, ooh. And then shake out your legs. Shake out your legs. Okay. Arms out. Quick little circle with the shoulders. Going forward. Go backwards. Your shoulders have probably got quite tense. So shake it out again. Then let's roll our shoulders backwards. So roll your shoulders backwards. And then roll your shoulders forwards. Okay. Then one last shake of the arm, shake of this arm, shake of this leg, shake of this leg. And then all we're going to do to get the blood pumping is 15 jumping jacks. This is a jumping jack, and we're going to do 15. In 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I feel like my body has got some air. I've also done some stretching to relax. And then the blood is now moving around my body. Now, guys, I'm sorry, because of time constraints today, we're not going to get to play Maths 24, which was the brain break puzzle. But in the next lesson, I promise you, I will explain to you what Maths 24 is. Siamtanda, I see your hand is raised. Let me see if I can allow you to answer. I'm out of breath. I'm like still trying to catch my breath. Okay, Rulani, let's go to you first, and then we'll go to Siamtanda after that. Can you hear me, Rulani? So, Rulani, I'm trying to unmute you. Can you hear me? Okay, there must be a technical issue there. So let me go to Siamtanda. Can you hear me, Siamtanda?
Yes, sir.
Yes.
So basically, I noticed that we made a mistake in the formula.
Ooh, did I make a mistake in the formula?
Yes,
Let's have a look.
like
49.
you wrote 12 instead of 6.
Did I write 12 instead of
Get
6?
12. Yes.
Ooh, you're right. Okay, guys, I apologize. I think that's probably what Rulani was wanting to look at, is we went from 2 times 6 is 12. Let's just have a look. 6 minus 7, 2. So that should be 12 though, because 2a is 2 times 6, which is 12. Oh, but I had 24 here. Okay, yep. So that's going to be 12. And then that's going to change the answer here. So let's just make that correction. Sorry, guys. Let me just make that correction. So 7 plus 1 8 over 12
1 over
is
2.
2/3. And
Okay,
then,
so 1 over 2.
so 6 over 12, which will be a half. Did you get that?
Yes, sir.
Thank you so much for spotting that. And then let's just make the correction here. If that is 2/3 and that is a half, then minus 2/3 minus 4 over 3 plus 2, that should be 2/3 as well. And then minus 2 times a half is minus 1 plus 2 is 1. Did you guys get that? Did you get 2/3 and 1 for y? Once you've made that correction? So just take a moment, check me on the calculator, then give me a thumbs up if you followed that. So the main thing that I just missed there a little bit was this should have been 2 times 6, which is 12, not times 24, which was the problem. Okay. I'm going to assume that that's okay. You can clearly see, and you can go over the recording just to see where that was if needed to. Okay, one last simultaneous equation, and then we're going to move on to do some inequalities. So here is your question. The sum of two numbers is 20. The product of the same numbers is 99. How would you write that out to set the simultaneous equation up? What would I write down? How would you write the sum of two numbers is 20 if you wanted to write out that? So you'd go X, Sange is on the money, X plus Y is 20. And how would you write out while the product of the same numbers is 99? How would you write that out? Rulani, you're on fire. Okay. Amelia, you're on fire too. So I want you guys to solve this set of simultaneous equations for me. I'm going to say that the yellow one is the easier one. And so I'm going to work with that one and sub it into this green one over here. But I want to let you guys fly solo and then tell me what answers for X you get. So what answers do we get here? What should we do, X or Y? I guess I'm going to do Y because it's the more common one. So I would get 20 minus X, and then I would rewrite that equation like that. And that would eliminate the Y, and then I have to do that. Okay, I've given you enough help. Give me my roots for this. Give me the values of X that you think it's going to end up being. What do you think the answers are going to be? So pop your answers in the chat when you have got your answers for X. Hmm. That's not going to work, is it? That should be positive. I made a mistake there. I knew it. Oh, so that should be plus 99 because it stayed there. That should be there. That should be there. That's fine. So 1, 1 minus 20. And then we're going to have minus 11 and minus 9. Thanks, Yamtanda. I must be getting tired now. So this has to be a plus 99 because it didn't move. So that's why, just in case you didn't catch that, this stays positive, whereas the 20x became minus 20x, and the minus x squared, it became plus x squared. So we have x minus 11, x minus 9. So what are the answers to what are the two possibilities going to be for my x values? So x is 9 or x is 11. And what are the two possibilities for my y values going to be? Oh, sorry, that was a bit much. So x plus y equals 20 are the two values there. But if you know x is 9, then y would be 11. And if x was 11, then y would need to be 9. So actually, this is the, 9, if x is 9 and y would be 11, if x is 11, then y would be 9. And then we're all good to go. All right. So that is another variation of the simultaneous equation we can do. So I just want to ask you, how are you feeling about simultaneous equations out of 10? Give me your feeling. How strong are you in simultaneous equations now, out of 10? Now that we did about 5 or 6 examples, and I went from the easy and I did a really hard one. And then I've done like a variation now. So I'm just keen to see how you're feeling now out of 10. Let me know in the chat how you're feeling. And then I know Siam Tanda wanted me to do a question on inequalities. So I've got about 10 minutes left, so I can do that if you guys don't mind. Give me your score out of 10, okay? And then are we happy to, okay, so Sange, what you need to do is practice some more of these, but there are some more practice questions you can do in the app. And I think, okay. So all we need to do, if you do more practice with simultaneous, I promise it will get easier. So what I'm going to do in the last 10 minutes is I'm just going to go grab, should I go and get an inequality question? Let's have a look. Actually, you know what, guys? I'm actually going to do one more simultaneous equation. I think we've done simultaneous the whole day. We should probably do one more like this. So let's do another simultaneous. Let's do this one. So we're going to end with this one. So, Simtanda, what I'm going to suggest is if you look at inequalities, there are some recordings from last year that you can look at. And so let's finish today with doing this. This will be our final question for the day. I think then we can know we did a solid hour on simultaneous, and you guys will feel like, okay, I've got this. Let's finish with this one. I'm going to let you guys fly completely solo on this, and I will just come and help you when towards the end. Okay, let's have a look here. So I would work with this one, and I would make it y equals x minus 3, and then I would sub it into that one equals that. See if you can go from there. Let me get rid of some of the stuff here. So if I bring this across, I get minus 3x, and then minus 3 plus 3. Oh, that's quite nice, because these guys knock each other out. So you get x squared minus 3x. So those two are gone. And then what we need to do is we get naught equals x minus 3. So what are my two solutions if I get that? So I think the way to do this bit, let me just do it up here because I'm running out of space. X equals naught, or x minus 3 is naught, in which case you've already got the answer there, and this will be x is 3. Okay, well, now you've got what x is. What is y going to be that goes with these two x's? Oh, let me zoom in rather. Yeah. So I think that I would use this bit up here. It's too dark. I would use, so we know that y is x minus 3. So if we know that x is 0, well, 0 minus 3 is just minus 3. And on this side, 3 minus 3 is 0. So the matching simultaneous solutions are the green ones and the yellow ones. And that is that for this evening. All right, everyone. So just recapping on what we did today, we learned how to solve simultaneous equations. We did primarily the method that's called substitution, which I would say that most students would benefit from doing. We looked for the easier equation, and we sub it into the harder one, and we eliminate one of the variables. Then we end up solving a simultaneous equation. Normally, we get two answers, and then we sub back those answers into the original simple equation to get the other values we need.